All right, welcome on my part as well. My name is Otto, and I'm here today to talk to you about next generation front-end development using Scala with Scala.js. I'm a co-founder and CTO at Microtask. Our office is actually in Tampere, so I'm visiting here in Helsinki today. So we've been using Scala on the server side for about 3 years now in our own product, and Scala.js on the front end for about 6 months now. Before that, we were using both GWT, which is a Java-based thing, not recommended, and Angular.js, also not recommended. So before we start, just to get a quick recap on the audience, how many of you are using JavaScript in your daily work? Hands up. Oh, surprisingly many. How many of you actually know Scala or have done something with Scala? And how many are using Scala in your daily work? All the Zalando guys, like 1 and 2. Okay. So first, to get you more active, what does this JavaScript do? It's a pretty simple piece of JavaScript that you can just quickly look and tell me what does it do. It's quite straightforward. Can you tell me, anybody? Just a few lines there. Come on, it's not that complicated. All right, so basically it just makes a AJAX request to Twitter to get some tweets, and once that request is completed, the JSON is parsed, and then the tweets go there using jQuery into the HTML DOM. Did you notice anything special about it? Something that doesn't sort of click? Maybe take a closer look. There's this kind of type definition, so this must be TypeScript. Later on, when Otto Hilska is going to be presenting TypeScript, I'm sure he's using the same example, because this would be actually valid TypeScript. But in reality, it's actually strongly typed Scala using Scala.js, so it can look very much similar to JavaScript. So what is Scala.js? Basically, it's a Scala to JavaScript compiler. You take Scala, you write application in Scala, you compile it to JavaScript, then you can run it in any browser, or even in Node.js if you really want to. It has a full support of the extensive Scala language. All the features of the language are there present, which is not a small feat, given that Scala is a very, let's say, extensive language with a lot of features, from functional programming to object orientation and so on. But you also get full JavaScript interoperability. So you can use all the libraries you know and love, like jQuery and React, whatever. Everything is there. You can use it quite natively from your Scala code. It just looks like using another Scala library. And also the compiler produces very fast, optimized JavaScript. It's usually about as fast as your handwritten JavaScript, sometimes even maybe a bit faster in some occasions. And the generated JS code is quite small. It's comparable to what you would write with your just doing it by hand. But typically you need to include a few Scala libraries in there, so it ends up maybe about few hundred kilobytes per a typical application after going through the Google Closure compiler. And doing modifications, compiling, running it is quite fast, usually 1 to 5 seconds. So it's not as fast as the other, let's say, JavaScript transpilers, but it's not that slow that it would bother you. And because the language is strongly typed, you don't really need to do this cycle that often, because the IDE and the compiler is there to help you quite a lot. But let's do a quick live demo to see a very simple use case of Scala.js. Let's see how this works. I hope you can all see this. So we have a browser here open, waiting for something to happen. This is just using a very simple, nothing there, just using Bootstrap to get it a bit prettier, having one div here as a base for where all our content is going to be. And this is basically the JavaScript that the Scala compiler is producing. So let's not go too far. So let's start by creating some content. And we always start with a div, of course. What else is there? Because we are using Bootstrap, we also want to use this container fluid. And within that container, we have another div. So this is all Scala code. There's nothing special here. It's not like JSX that you would need to run some kind of preprocessor to get it. It's just normal code that is being type checked all the time. So let's add a row. And within the row, we need to have a couple of columns. Oops. Let's put 12 because we don't need to be responsive in this demo that much. And maybe a quick hello world there, like that. And there we have some content, and now we just need to append it to the div that we have within the HTML, and we are done. Except we now see a type error because we need to render this to actually make it a real DOM element. Now we save it. We are now seeing it's compiling the source code, and there we go. We have a hello world. Whoa, it's working. Great. Let's add a little bit more interactivity there by introducing an input element. As you can see, I get all these suggestions that what could I put here. I don't need to go and Google for something that, okay, what was the name of that? I just get the placeholder, and let's put country in there, and this time we remember to render it. And there we go, just add it to the DOM just like any other element. Save, it will automatically compile and update. And because it's actually not refreshing the page, it's updating just the JavaScript. So now we are appending more childs there, so we get it actually twice. So let's add a quick cleanup phase there, get the inner HTML empty, and that should. And you can see it's like 1-2 seconds, this iteration to make these changes. And here we have a normal input box. Let's add a div there that we can actually show some results out of the text box. Result. And then, because the text box is an input element, it has all these events. Let's use the onKey up. We add a normal event handler. It gets an event. And as you can see, this has been strongly typed all the time, and this is the first time I actually need to write the name of the type that I'm using here, just in the function definitions. And here we basically just want to put the text content, or put the text box value into the text content of that div. And again, it's 1 second later, we now see some, let's say, at least one directional binding happening just in a few lines of code. But let's make this more interesting. Let's add some actual countries here. Just a sequence of them. I made a quick list of some countries, so I don't need to spend half my presentation typing them in. And now we are not actually putting text content, we are generating some HTML here. So let's now remember to empty it first. And then we will be appending something. Let's use an unordered list. And because we are using Bootstrap, it has this nice list group class that we can utilize. And then for the actual content, we would like to use the countries, and then basically filter all the countries based on, so if, let's use lowercase so that we can make it a bit easier. So if the country name starts with whatever we have in the text box, then we get it into the list. Let's make that lowercase as well. And now we just get something that, as you can see, the red line, it doesn't compile at the moment, so we need to map it to the list elements. Let's make a list element, and again some Bootstrap classes there, list group, item, and then t and then finally we need to render it. And as soon as it compiles, it works okay, and now we can start filtering the list based on whatever I'm writing here. Okay, so that was the quick demo just to show how Scala.js works and how easy it is to work with it. It's just like JavaScript, except you have all these nice things in there and you don't make any mistakes. All right, so let's get back to the slides. So there are literally about 160 different languages or transpilers that compile into JavaScript, because JavaScript is a great platform. It's well supported. When you make a JavaScript application, you can run it on all kinds of devices, so it's really like a lucrative target to use. But why do all these different things exist if you just have JavaScript? Why don't you all just do it in JavaScript? Well, basically everyone wants a better JavaScript. It's a great platform, but the language is, it's not, let's say it's not so great. ES6 makes it much better, but it's still not quite there. Safety is one thing. You don't want everything to break up in your production, this kind of uncaught type error, undefined function, this and that. You want safety against your own mistakes, so that you use a linting tool or compiler so that you don't make those mistakes. You want more modular, especially as the application sizes are growing very rapidly. You want more expressivity, like CoffeeScript is very expressive. You can do more with less code. You want to have it reusable so that you can build libraries and use them in other applications. And also you want one language across client server, not just to have like common code, but also be able to use the same developers on both the client and server side, so that you can iterate faster, that you don't need to, the server guys don't need to wait for the client guy, or the client guy doesn't need to wait for the server guy. They can both do the same things. You also want more tooling and better IDE support, so that whenever you make mistakes, you get them right there in the IDE without actually running it in the browser and then getting that uncaught type error exception. And of course, few words, we all have seen this happen in JavaScript. It's very easy to make mistakes that you don't sort of notice until it's a bit too late. So why Scala.js out of all these other options? So ES6 brings great benefits over ES7. It's much more expressive. You get all the nice things like the fat arrow functions and so on. But it's still untyped. You don't get any benefit over there. The tooling is still, you just use your normal editor because the IDEs cannot really help that much. Interoperability is of course great. TypeScript, you get types. Today we are going to be hearing more about TypeScript later in the other presentation. You also get much more tooling support because of the types, that the IDEs can understand what your code actually means and what you are trying to do. ClojureScript, quite popular these days, but it's still untyped. It's based on Lisp, Clojure, so it's a functional programming language, so it's a very powerful language. But the tooling is, again, because of lack of static typing, is not so great. So you get a lot of this cognitive load that you have to remember many things so that you are productive. Dart, a new thing from Google. Again, types are there. It's about 50% JavaScript, 50% Java, whether that's a good thing or a bad thing. And the tooling is quite okay for Dart as well. But the interoperability both of ClojureScript and Dart is not so great. It's more like an afterthought there, that okay, you want to write everything in Clojure, you want to write everything in Dart, you don't really want to do anything with JavaScript. Unlike in Scala.js, while it's a very strongly typed language, it has an extremely good interoperability. As we saw, the language itself is quite close to JavaScript, so it's easy to adapt compared to something like ClojureScript, which is totally different. And the interoperability has been there from the very beginning, a very important part of how Scala.js works. So you can call JavaScript functions just like you would call Scala, and it works in the other way around, as we saw with that event handler. It's just a Scala function that we give to the JavaScript, and everything just works nice. And the tooling is great. So why now? Why are all these other alternatives to JavaScript arising now and why there is more popularity for them every day. So we need to look at how the front-end development has been evolving over the years. So it all began in the Stone Age, which we can also call jQuery era. But the fact is that majority of JavaScript development is still in the Stone Age. Minority of JavaScript development happens in using advanced frameworks and so on. Majority is still there, where the server is doing all the HTML rendering and the JavaScript is just used to do some simple animations, maybe an AJAX call to the server to get some live updates, and then just do direct DOM manipulation with jQuery syntax to do whatever you need to update. But luckily people saw that, okay, this is not really the way to go, so we enter medieval times and we see the rise of the single page app, so that the server is now reduced to just give me data. I don't want HTML from the server. I have all these HTML templates on the client side that I'm using for rendering, so the JavaScript is now actually driving the application. It has a much bigger role than before, and the REST APIs are being used to call the server. So we get all these frameworks like Backbone and Ember and Angular from this era. But of course, complexity grows, applications grow, people start to see the limitations of this approach. So we get new architectures like React, which is much more JavaScript centric, that everything is now JavaScript. Even the DOM is being generated in JavaScript. Just like in my example, the code is generating the DOM. It's not an external HTML template anymore. We also see new kinds of ways of interacting with the server. It's not just the REST API, it's much more, let's say, JavaScript friendly, these GraphQL, Falk, or other things. And also all these different kinds of transpilers, TypeScript, Bubble, and these are coming up because people want to use all the new features. They don't want to wait for browsers to catch up. So first we had all the polyfills, and now the transpilers are doing much of that. But what about the next generation? This is now maybe what people are just starting to use, but what is the development going to be in the future, in the modern times, let's say. So we see the rise of new languages. Instead of JavaScript, people start using Clojure, Dart, TypeScript, and now even Scala. The complexity of the applications is ever more rising. We see the need for, let's say, offline functions, so we can't talk to the server anymore. So we need to duplicate more and more of the functionality on the server side, also on the client side, sharing the code. And this means that JavaScript is sort of reduced to a compile target. So it's like the x86 assembly language on the web. It's still the platform underneath, but people are not really targeting it just like that, but are using a higher level language. I would even say that, let's say all the people in this room, in 5 years, none of you are going to be writing plain JavaScript. Everybody's using some kind of transpiler, some kind of advanced features on top of that. And that's okay. It's the way the world works. And now we're also seeing a lot of development on let's say, cross-platform between mobile and web. It used to be that on the mobile, you would just have this web view, a sort of mini browser view within your application where you would run the same code as you would run on the web. But now with React Native, you can actually write your application in Scala, compile it to JavaScript, and run it natively on iOS or Android. So it's really interesting to see what will happen there. Let's say we have enough time, so I'll just show you another quick thing. This is a tutorial I made basically to learn Scala.js myself. So this is a very simple tutorial using React. We have just these couple of views, like typical to-dos, and nothing special here. Something you would do quite quickly, except it's not. Okay, now it's loading. So it's updating something from a server. So if you look at what like real Scala.js application would look like, this is again a really simple one. But this is now basically creating a React component called Message of the Day. And this is using a Scala.js React library that's built on top of React. It's exposing the React features in a more Scala way, more, let's say, functional programming way. So you see sort of familiar things in there, component did mount, and all these things are coming from React. But let's focus on how we get the data from the server. We are using this Ajax client class, which is calling the message of the day function, and somehow magically something happens and it gets the response from the server, and we get a message which is a string, and then we just go and modify the state of the component with the message, and then we render the message with the new content automatically. But what makes this interesting is how this is all defined. Basically, I have this API defined, like an interface, which is called trait in Scala. Here I'm basically defining that what the server can do. And this is all I need to do. Then everything else happens automatically. The Ajax client will generate the relevant JSON or other serialization, that what I need, how do I pass the parameters to the server, how do I call it, and so on. It all happens automatically. So on the server side, we can see that I have this API service, which is extending the API, and here I have the method for returning the message of the day. Now what makes this interesting is because this is one application, so I could go and refactor this name, and it would refactor it both on the client side and on the server side, so they always stay in sync. But if I just go and let's modify this as a welcome message, now the interface is changed, and if we look at the API implementation, we see that now the IDE is complaining, okay, this is not great. You are doing something wrong here. So I need to go and fix it so that it works. But then when I go to the client side, again I see that error. So I get all this benefit from the compiler and the IDE, that I don't need to think that, okay, where do I need to do this kind of regex search over all my code base and try to find all the instances of this function call, but I can just change it like that, and it works just fine. And also the navigation is quite easy. I can just go and see that, okay, where do I actually call this message of the day? This is the dashboard. I'm just using it as a component over there. And this is maybe interesting to JavaScript developers. This is not an operator, it's a name. So in Scala, you can use all these things. You can generate your own operators. They are just functions like anything else. So you can, if you see some, let's say, more complicated Scala code, there might be some really weird, let's say, Unicode operators. You could use emojis as in your code if you want to make it really, really complex. But yeah, okay, so that was the quick second demo. So what do JavaScript developers actually get from Scala.js? Why would you let go of all your JavaScript and start learning a new language like two people in the room were actually using it? Well, basically you get everything you have in ES6 and ES7. You get the fat arrows, you get the destructuring, you get string interpolation, you get async await. And all this has been there in Scala for many years. It's not something that's just out of the oven or just about to arrive. You don't need anything special to do with it. You also get everything you have in TypeScript. You have the strong types, you have the generics, and all the benefits you get from that. And you also get something like immutable.js, immutable collections. This is like the latest craze from Facebook, that okay, this is where the JavaScript should go, that everything is immutable, everything is functional programming, and so on. You know, like immutable.js is modeled after Scala and Closure collections, so they are just taking whatever is there and doing it again in JavaScript. Plus, you get a great language. It's really fun to develop in. You don't get all those JavaScript words or other problems. It's really nice. You get a really extensive standard library. You don't usually need to go outside that for the basic stuff. You don't need anything like Lodash or _.js. You get access to real functional programming with all the functional programming libraries out there, but you still can access all the JS libs there. You still can use all the visual components out there. You don't need to rewrite them in Scala to use it. But you also get this peace of mind that you don't need to worry that when you make that quick fix at 2 a.m. in production to fix that critical bug, you can go back to sleep and be sure that it doesn't crash.
Why was there a critical bug?
Well, you can still make programming errors. It doesn't protect you from that. Even though some of these libraries, like the Scala.js React, goes way over its head to try to force you to not make mistakes. It tries to force you to write code that's really safe. Sometimes it's a bit annoying even. So if you got interested, you head up to Scala.js.org, or actually we are now writing a new website. It should be live in a week or so. You can use the other URL to access the beta version at the moment. Or you can join the Jitter room to chat with other people. There are like 550 people there already. So that's it. Any questions?
How big is the runtime you have to download before the Scala or the JavaScript runs, like standard libraries and all sorts of stuff?
So the way the Scala.js compiler works is it does this what's called full program optimization. So it takes your code, it takes all the libraries, which is like 20, 30 megabytes of Scala code compiled to bytecode. So it's really huge. If you would have all that in your code, it would be like 100 megabytes. But it has an optimizer, so it's doing this tree shaking. It's basically inclusive optimizers. So only the code that you actually use gets included. So that ends up being about, for the simple hello world, it's about maybe 90 kilos. For something more complicated, using more libraries, maybe 400, 500 kilos before gzipping. Yes. Yes, so the question was about source mapping. Yeah, yes, it generates source maps, so you can just go in the browser. But basically you have source mapping, so if you get an exception, you actually see in the stack trace that your original Scala code and where it happened, and you can go in the browser, set breakpoints in your Scala code, and they will be in the correct place in the JavaScript code. All right, did we spend 40 minutes already?
I think
more or less.
Thanks for your time.
Okay, thank you.